Hi everyone, this is our second video for the solutions to the 2024 HSC Maths Advanced exam. In this video we're going to cover questions 11 through to 22. Question 11. The graph of the function g of x is shown. Using the graph, complete the table with the words positive, 0 or negative as appropriate. So from the table we can see various x values. We want to know the sign of the first derivative and the sign of the second derivative at those points. So let's start with our first derivative. Now remember that when the curve is increasing, the first derivative will be positive. When it's decreasing, it'll be negative, and when it's stationary, it will be 0. All right, so what have we got? Let's have a quick look. At x is equal to -3, we are increasing, so positive. At x is equal to 1, we are stationary, so 0. And at x is equal to 5, we are again increasing. So let's write that in. We've got positive here, 0, and positive. Now the second derivative, remember, tests concavity. So concave up is positive, concave down is negative. And if we've got a change of concavity, then it's 0. So at x is equal to -3, we are concave down, so negative. Here, we have a change in concavity from concave up to concave down, so it'll be 0 there. And here we're part of concave up, so that'll be positive. So filling those in, at x equals -3, we're concave down, and then changing concavity, and then we are concave up. Question 12, find the sum of the terms in the arithmetic series. So sum of n terms is equal to n over 2, 2a plus, and brackets n minus 1 times d. Okay, so we know a is equal to 50, and we can see here that the common difference is equal to 7. We actually don't know what n is, do we? So we're going to need to work that out first. So let's do term n is equal to 50 plus n minus 1 times 7, and this one here is equal to 2024 is equal to 50 plus 7n takes 7, and so 2024 is equal to 43 plus 7n. 7n is equal to 2024. Let me just grab my calculator. 2024 take away 43 is 1981. And so n is equal to 1981 divided by 7, which hopefully is an integer, and it is 283. Okay, now we can substitute it in. So we want the sum of 283 terms, which is 283 divided by 2. 2 lots of a is 100, plus n minus 1 is 282 times 7. I'm putting that all into our calculator. And we've got 100 plus 282 times 7, close brackets, is, wow, that's a big number, 293,471. Question 13. The graph shows the populations of 2 different animals, W and K, in a conservation park over time. The y-axis is the size of the population, and the x-axis is the number of years since 1985. Population W is modelled by the equation y is equal to a times 1.055 to the power of x, so this is W here. Population K is modelled by the equation y equals b times 0.97 to the power of x, so this is K here. Complete the table using the information provided. So the first thing we need is the population population in 1985 for population K. So we need to know this here, this y-intercept, which is 280. The percentage yearly change in the population, so that's in here. You can see that this is the same as 1 plus 5.5%, treat it like compound interest. So that's got a yearly change of 5.5%. And here, this one will be 1 minus 3%. So minus 3%. And then finally, the predicted population when x is equal to 50, we've got population K because we can see that on the graph, but w is off the graph, so we need to use our formula. So y is equal to 34 times 1.055 to the power of 50. Putting that in the calculator, we get 34 times 1.055 to the power of 50 is 494. Question 14a. The curves y equals x minus 1 all squared and y equals 5 minus x squared intersect at 2 points as shown in the diagram. Part A, find the x coordinates of the points of intersection of the two curves. So let's do simultaneous equations. I'm going to put these two curves equal to one another. So x minus 1 all squared is equal to 5 minus x squared. X squared minus 2x plus 1 is equal to 5 minus x squared. 2x squared minus 2x minus 4 is equal to 0. Divide everything by 2. X squared minus x minus 2 is equal to 0. Factorise. X, 2, 1. I want the bigger one to be negative, so minus plus. Therefore, x is equal to negative 1 and positive 2. Part B, find the area enclosed by the two curves. So we want to set up an integral. Our area is going to be equal to the integral between negative 1 and 2. And we want the top curve, which is the one that's concave down, so this one. 5 take away x squared, take away the bottom curve, which is this one. X minus 1 all squared dx. Now, we could expand that all out. Actually don't need to. We can integrate it as it is. So we're going to end up with 5x take x cubed on 3, take away. Here we've got a reverse chain rule, so x minus 1 all to the power of 3 divided by 3. Divide by the derivative of that inside function, which is just 1. Between negative 1 and 2 equals, substitute in, 5 2s are 10, take away 8 on 3, take away 2, take away 1 is 1, 1 cubed is 1, so 1/3. Take away brackets, because I'm going to substitute that negative 1 all the way through. Negative 5, take away, negative 1 all cubed is negative 1, so it'll turn that to a plus, 1/3. Take away, putting the negative 1 into here, negative 1, take away 1 is negative 2, negative 2 all cubed is negative 8, so that'll turn that to a plus, over 3. And now we just need to put that in our calculator, and we are done. 10, take away 8/3, take away 1/3, take away brackets, negative 5 plus 1/3 plus, where's the plus one there? 8/3, close brackets, is 9. And it is an area, so 9 units squared. Question 15. Initially there are 350 litres of water in a tank. Water starts flowing into the tank. The rate of increase of the volume V of water in litres is given by dV dt is equal to 300 take away 7.5 times T. T is the time in hours. Find the volume of water in the tank when dV dt is equal to 0. Okay, so we need to first figure out when this is going to happen, and that's easy. We're just going to put this equal to 0. So 300 is equal to 7.5 T. T is equal to 300 divided by 7.5, which is equal to 300 divided 7.5 is 40. And what are the units here? Hours. Find the volume of water in the tank when T is equal to 40. Okay, so we need to integrate this. So V is going to equal the integral of 300 take 7.5 T dt is equal to 300 T minus 7.5 T squared on 2 plus C. Let's resolve the constant. Initially, so when T is equal to 0, V is equal to 350 So if we substitute that into here, we're going to get 350 is equal to 0, take 0 plus c. c is equal to 350. All that remains to do is to substitute in t is equal to 40. So that's 300 times 40. Take away 7.5 times 40 squared on 2 plus 350. And in the calculator, 300 times 40 minus 7.5 times 40 squared divided by 2 plus 350, 6,350 litres. Question 16. Flowers were planted in two gardens, Garden A and Garden B. On a particular day, 25 flowers were randomly selected from each garden and their heights measured in millimetres. The data are represented in parallel box plots. Compare the two data sets by examining the skewness of the distributions, the measures of central tendency, and the spread. Okie doke. So let's start with the easiest thing. We can see that on average, Garden A's flowers are taller. So comparing the medians, the median for Garden A is greater than the median for Garden B. On average, Garden A's flowers are taller. Okay, so there's one. Two, let's talk about spread. Now, probably the interquartile range is best here, so that's this distance here. And we can see that the heights of Garden B's flowers are more consistent. They're less spread than Garden A's. So we'll say the interquartile range for A is greater than the interquartile range for B. Therefore, heights of A's flowers are more spread than B's heights. Now let's talk about skewness. So 3. Now remember these are quartiles. So a quarter of the data, a quarter of the data, a quarter of the data, a quarter of the data. Can you see it's more bunched here and more spread out here? If we drew this as a dot plot, it would look something like this, spread out, bunched together. And so that is a negative skew, has a negative skew. Now B is completely different. All the bunching occurs on the left-hand side, so it would look like this. And so B has a positive skew. 17a. In a particular electrical circuit, the voltage V volts across a capacitor is given by this equation. K is a positive constant, T is the number of seconds after the circuit is switched on. Part A, draw a sketch of the graph of V of t showing its behaviour as t increases. All right, let's start with the graph of e to the kt, which looks like this, as a y-intercept of 1. So this is e to the kt. When I put a negative in front of the t here, it's going to reflect it in the y-axis like that. So this is e to the negative kt. Then I'm putting a negative in front of that whole thing here. So that's going to reflect this over the x-axis. So this is negative 1. This one is negative e to the negative kt. And then I'm going to move it up 1. So this is our final graph here. I'm taking this one here and moving it up 1. Like that. You can see I've completely ignored the 6.5 because that's only just going to change the steepness of it. Everything else is going to stay the same. And we're not going to put anything on the axes. So this is the graph of y is equal to 6.5 brackets 1 minus e to the negative kt. Now, show its behaviour as t increases. As t tends to infinity, v of t tends to 6.5, 1 minus, and this thing here tends to 0, equals 6.5. So to show that on my graph, I'm going to put an asymptote in here, and that is 6.5. When t is equal to 1, the voltage across the capacitor is 2.6 volts. Find the value of K, correct to 3 decimal places. So let's just substitute that in. 2.6 is equal to 6.5, 1 minus e to the negative K, and t is 1. Divide both sides by 6.5. 2.6 divided 6.5 is 0.4. Okay, quick math. Take this over that side and this over this side. I end up with e to the negative k is equal to 1 take away 0.4, which is 0.6. All right, let's take this out of index form. We end up with negative k is equal to ln 0.6. And so k is equal to negative ln 0.6, and we want it correct to 3 decimal places. So negative ln 0.6 is 0.511. Part C. Find the rate at which the voltage is increasing when t is equal to 2, correct to 3 decimal places. Right, so rate means derivative. I'm just going to expand this out to make my life a little bit easier. Minus 6.5 e to the negative k was 0.511 t. So v dashed of t is equal to negative 6.5 e to the negative 0.511 t times by the derivative of the inside function, which is negative 0.511, equals 6.5 times 0.511 is equal to 3.3215. 3.3215 e to the negative 0.511 t. And we want it at t is equal to 2, so v dashed of 2 is equal to 3.3215 times e to the negative 0.511 times 2 equals times of negative 0.511 times 2 is 1.195 volts per second, correct to 3 decimal places. Question 18a. In a game, the probability that a particular player scores a goal at each attempt is 0.15. Part A. What is the probability this player does not score a goal in the first 2 attempts? And so that is here, isn't it? And probably they don't score a goal is 0.85 and 0.85. So probability of no goal and no goal is equal to 0.85 times 0.85, which is 0.7225. Part B, determine the least number of attempts this player must make so that the probability of scoring at least 1 goal is greater than 0.8. So let's just draw up that probability tree again. We've got goal and not a goal, and goal, not a goal, goal, not a goal. All right, so the probability at least 1 goal, remember that is 1 take away the probability that you don't score a goal at all, which is what we just worked out, which was 0.85, and in that case squared. Now if we want to take that to the nth degree, it's going to be 1 take away 0.85 to the power of n. So that's the probability that they score at least 1 goal in n attempts. And we want this to be greater than 0.8. All right, again, we're going to do that fancy thing that I just showed you. So 1 take away 0.8, 0.2, greater than 0.85 to the power of n. Take logs of both sides, so ln 0.2 is greater than ln 0.85 to the power of n. This is our third log law, so ln 0.2 is greater than n ln 0.85. Now we want to divide both sides by ln 0.85, but here's the problem. This is negative. Like ln of 0.85 is negative 0.16. So when I divide by a negative with an inequality, it's going to switch this inequality sign. So this is going to become ln 0.2 divided by ln 0.85 is less than n. Now, if you reckon that you're not going to, think of that, what you can always do is actually just solve an equation. So ln 0.2 equals n ln 0.85, and then test your answers. I'll show you what I'm talking about in a second. Let's keep going with this though. So switching that around, n is going to be greater than, let's work that out, ln 0.2 divided by ln 0.85. And so it's 9.9. So providing n is greater than 9.9, say 10, we're going to get the probability of at least one goal is greater than 80%. So therefore, n has to equal 10. So back to what I was saying before, we could test the answers here. Test n is equal to 9. 1 take away 0.85 to the power of 9, you will get around 77%. And 1 take away 0.85 to the power of 10, you will get 80%. Question 19. Sketch the curve y equals x to the power of 4 minus 2x cubed plus 2 by first finding all stationary points, checking their nature, and finding the points of inflection. All right, let's start with stationary points. So dy dx is equal to 4x cubed minus 6x squared, which is equal to 2x squared, 2x minus 3. And let's solve that, equal to 0. We've got x is equal to 0 and 3 halves. Now we want the points, so we need the y coordinates as well. So when x is equal to 0, y is equal to 2. And when x is equal to 3 halves, y is equal to, let's substitute that in, to the power of 4 minus 2 times 3 halves cubed plus 2, 0, I can put that as a fraction, 5 over 16. Actually, I don't know whether I want that as a fraction. What was it? 0.3. Because we're going to be sketching it, aren't we? Now let's find any points of inflection. So we need the second derivative is equal to 12x squared minus 12x. Factorising 12x, x minus 1. And we want to solve this equal to 0. So we've got x is equal to 0, which we already know about, or 1. Let's find the y coordinate. At x is equal to 1, y is equal to 1 take 2 plus 2, which is equal to 1. And so we have an inflection at the point 1, 1. Now let's use our second derivative to test the nature of our stationary points. Now we already know that at x is equal to 0, our second derivative is also equal to 0, and so this is a possible horizontal inflection, and we will need to investigate further. But at x is equal to 1.5, our second derivative is equal to 12 lots of 1.5 squared take away 12 lots of 1.5, which is equal to 12 times 1.5 squared minus 12 times 1.5, 9. 9, which is greater than 0, so concave up, it is a minimum. Okay, so first derivative test, for this. Let's test -1, 0, and then 1. Now we know at x is equal to 0, our first derivative is also equal to 0. When we put -1 in here, we're going to get -4, take away 6, it's negative. When we put 1 in here, we're going to get 4, take away 6, it is also negative. So we've got decreasing, 0, decreasing. It is a horizontal inflection. We're ready to sketch. Now notice how it doesn't say anything about x-intercepts, so we don't need to worry about it. We do have a y-intercept though at 0, 2, so we should put that one in. So we're going to need to look at 0, 1, and 1.5. So we've got 0, 1, 2. And we've got a horizontal inflection at 0, 2. So that's here. And we have got a minimum at 1.5, 0.3, so that's somewhere down in here. Say, an inflection at 1, 1. Now we know this is a quartic curve and it's a positive one, so we're expecting it to start at the top and end up the top and do something like this in the middle. So how can we do that? It's going to come down like this. It's got an inflection there, horizontal inflection. It goes from concave down to concave up at this point and then heads back up. And we just need to label a few things. So here we have got horizontal inflection at 0, 2. We have an inflection here at 1, 1, and here we have a minimum at 1.5, 0.3. And this is x and this is y. Question 20a. A vertical tower TC is 40 metres high. Point A is due east of the base of the tower C. Angle of elevation to the top T of the tower from A is 35 degrees. The second point B on a different bearing from the tower is shown. The angle of elevation to the top of the tower from B is 30 degrees. Points A and B are 100 metres apart. Part A, show the distance AC, that's here, is 57.13 metres, correct to decimal place. All right, that's just trig, isn't it? So let's let this be x. Tan 35 is equal to 40 over x. X is equal to 40 divided by tan 35. And on the calculator, 40 divided 10, 35 is 57.13. Good. Meters. Part B, find the bearing of B from C to the nearest degree. Okay, let's draw a bird's eye view of this. We've got A here and B out here. We know the distance between them is 100. We know this length is 57.13, and we want to find this angle and then add 90 to it. We don't have enough information because we don't know this side. So we can do exactly the same thing that we just did, but with this triangle here. Okay, so it's tan again, so tan 30 is equal to 40 on, let's call this y. And so y is equal to 40 over tan 30, which is 40 divided by tan 30, 69.28, which is here. And now we're ready to work out theta using the cosine rule. So cos theta is equal to 69.28 squared plus 57.13 squared, take 100 squared, all over 2 times 69.28 times 57.13 is equal to 69.28 squared plus 57.13 squared minus 100 squared on 2 times 69.28 times 57.13 equals negative 0.2446, and so theta is equal to inverse cos of the answer, which is 104 degrees. Now we want that to the nearest degree. So therefore, the bearing, I'm running out of room, so you'll have to write this, the bearing, or maybe I can do it, of B from C is, add 90 to that, 194 degrees. Question 21. A researcher is studying anacondas. Dataset recording the age in years and length in centimetres of female and male anacondas is displayed on the graph. Anacondas reach maturity at about 4 years of age. Write 3 observations about anacondas that may be made from the scatter plot. So we want 3 things. If we draw up, here's the female data set through here, and here's the males through here, and there's maturity at that point. Alright, we can see, firstly and obviously, females are longer than males. So that's obvious. We should talk about the rate of growth. So we can see that, particularly after 4 years of age, the rate of growth for males slows right off, but it continues or seems to continue for females. So after maturity, the rate or the growth rate for females is greater than the growth rate for males. And we want a third thing. And I'm just going to rub all of that out. I think the third thing, for me anyway, is that in the beginning, they're pretty much the same. Can you see that? So up until 1 year of age, so up until 1 year of age, the lengths for males and females is pretty much the same. Question 22a. The graph of the function f of x is equal to ln brackets 1 plus x squared is shown. Part A, prove that f of x is concave up for -1 through to 1. Alright, so we want the second derivative. So f dashed of x is equal to 1 over 1 plus x squared times by the derivative of the inside function, because this is a chain rule, which is 2x. Our second derivative, we are going to have quotient rule here. So let's rub that out and work it out. So we've got u is equal to 2x and v is equal to 1 plus x squared. U dashed is 2, v dashed is 2x. And so f double dashed of x is equal to v times du minus u times dv all over v squared. Let's just tidy that up a bit. We have got 2 plus 2x squared minus 4x squared. We leave that denominator factorized, is equal to 2 take away 2x squared, and factorizing the top, we end up with this. Run out of room. Now for this to be concave up, so to be concave up, we want our second derivative to be greater than 0. So we need to solve this greater than 0. Okay, denominator, that is always positive. So there is no effect if I multiply both sides by 1 plus x squared or squared. So that's going to give me 2 brackets 1 minus x squared is greater than 0. 1 minus x squared is greater than 0. Let's factorize. We've got 1 minus x, 1 plus x. And I'm just going to draw a simple sign diagram. Our critical points are our zeros. So what makes 0 here? What makes 0 here? Which is 1 and negative 1. And let's test some points. I always start by testing 0. I'm going into here. 1 take away 0 is 1. Is 1 greater than 0? Yes, it is. Let's test negative 2. Putting negative 2 into here. 1 take away negative 2 all squared. Negative 2 all squared is 4. 1 take 4 is negative 3. Is negative 3 greater than 0? No, it's not. And finally, it's test 2. We're going to get the same answer, aren't we? 1 take away 4 is negative 3. Is negative 3 greater than 0? No, it's not. And so our solution to this is x has to lie between negative 1 and positive 1. Part B, a table of function values correct to 4 decimal places for some x values is provided. Using the function values provided and the trapezoidal rule, estimate the shaded area in the diagram. Now this is a bit of a mean question because as you look through these function values, you don't have any negatives. And we have more function values than are shown on the diagram. So a little bit mean, but we can manage. Our area, therefore, is going to be approximately equal to 2 lots of this area. Okay, now using the trapezoidal rule, it's going to be h on 2, we'll work out h in a second, f of 0 plus 2 lots of f of 0.25 plus 2 lots of f of 0.5 plus 2 lots of f of 0.75 plus f of 1. Now h is the height of the strips. So we can go 1 take away 0, so where do I write that? H is equal to 1 take away 0, and the number of strips is 1, 2, 3, 4. So it's a quarter. So our area is now going to be equal to 2. Actually, those 2's cancelled out. So it equals a quarter. And let's substitute our values in. 0 plus 2 times 0.0606 plus 2 times 0.2231 plus 2 times 0.4463 plus 0.6931, and put that in the calculator. So I've got 0.25 times brackets 2 times 0.0606 plus 2 times 0.2231 plus 2 times 0.4463 plus 0.6931, and close our brackets. Hopefully I'll get the right answer. It doesn't say how many decimal places to give, so I'll give 3. 0.538, and it is units squared. And part C, is your answer to part B an overestimate or an underestimate? Give a reason for your answer. Now, because of its concavity, because it's concave up, it's going to be an overestimate. If you draw in all the 0.25s and the 0.75, you're barely going to see the difference on the graph. But if we just took 2 points, like the 0.5 and here, maybe we could see a difference. Yes, you could here, look. So as we draw up our trapezoidal rule there, you won't see it so much there, but you can see that the trapeziums are going to sit above the curve because of the concavity of the curve. So we're going to say, okay, it is an overestimate. The trapeziums that we use in the trapezoidal rule will sit above the curve and draw a picture due to the curve being concave up. Okay, that's it. In our final video, we're going to look at questions 23 through to 31.